Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Okay, so I already sent you the new link for your attendance. So nanti boleh key in lah dekat attendance tu. Nanti waktu tutup nanti kita tengok apa yang belum key in lagi lah. By the way, laptop saya kan ada masalah kan. So disebabkan dia baru keluar daripada klinik semalam, there's a lot of thing that I haven't set up lagi. Masih ada banyak benda masih belum set up, so I cannot use my writing board. The writing board tak boleh guna, and then tak boleh guna apa lagi. Banyak lah account saya yang saya kena set awal. So nak cerita kiranya hari ni mungkin saya payah sikit lah untuk saya nak tulis tu. But let us do our best kan. Sehari ni dia ada fun sikit. Sebab laptop ni saya reformat. Habis hilang semua benda. Okay, so now let us start with a new chapter. Chapter 5, Functions and Graph. So basically for function and graph, you will need to know how to sketch the graph. And then you need to know what does it mean by restricting the domain, restricting the range. So kita akan buat restriction untuk domain, restriction untuk range. And then you must know how does a basic graph looks like. And then what else? You need to know how to do a composite function, the inverse function. And then we have a new function called the exponential as well as logarithmic function. If I'm not mistaken, you haven't learned them in your high school level. Kalau tak silap lah. Okay, let's see. So table of contents. So in chapter 5, we have 4 subtopics. So the first one, we are going to learn about functions. All about functions, how to sketch the basic graph and so on. The domain, range, and what else? That's all. Composite function, need to find out how to do G with F, F composite with G, and then if let's say the composite function is given, how to find either one of them, either the G or the F. So those are for the composite function. The inverse function, let's say we have G, so we want to find G inverse. We want to reverse the process. So that is when we learn about the inverse function. And then a new function, the exponential and logarithmic function. So exponential dengan logarithmic function, we are going to learn how to sketch them. And then how to find the domain range and how to do the composite function involving the exponential and logarithmic function as well. So altogether we have 4 subtopics. Okay, so the linear outcome for today, you should be able to define what is a function. So what do we mean by a function? And then how to identify a function, vertical line test. And then identify a one-to-one function by using algebraic or the line test. And then you're able to sketch the graph of a function. And then state, main, and range of a function. Okay, so now let us proceed with A, define a function. Okay, functions. Okay, so let's say X or 5 and Y is 6, 10, 12, and 13. Okay, so if you use an arrow diagram for them and they are going from A to B. Tengok boleh buat ni tak? Dia tak boleh nampak ni tak apa. Okay. Right, so an arrow diagram, this is set A, set B. So 3 is going to 6, 4 is going to 12, 5 is going to 10. Okay, and then, so this is an arrow diagram. We have another one ordered pair. So this is the pair. So we have 3, 6. So 3 is on the left hand side, 6 is on the right hand side. So ordered pair. So that is basically how we illustrate our function. Okay, so on the left hand side, those are called as the domain. On the right hand side, those are called as the range. Okay, so domain will be 3, 4, 5. Range will be 6, 10, 12. And codomain is exactly everything over here. So 6, 10, 12, and 13. So range, if let's say we go from domain to range, so we must have domain and arrow to the range. But codomain is simply everything inside the set B. Okay, so those are the differences between them. Okay, so what are actually a function? Okay, so function is a relation where every element of one set is mapped to exactly one element of another set. Okay, so for example, you might have either one-to-one relation or many-to-one relation. Okay, so those are known as, for function, we only have two relation, either one-to-one or many-to-one. Okay, so the most important thing is on the right hand side over here. This one need to be one. Yang sebelah kiri ni boleh one-to-one or many-to-one. So those are known as function. Okay, so function f mapping element x to y is written as y equal to fx. So f is the function mapping element x to y. Okay, so let us illustrate them. Okay, so a function is on 2 when its range equal to its codomain. Okay, so for example over here, this is A and B. As you can see, A is going to 3, B is going to 2, C is to 1. Okay, so this one, A is going to 3, so that means this is 1 to 1. And then since we use everything for this codomain, this is 1 and on. Okay, the second one, right? So if A, you have B. Okay, so basically for A is going to, this A is going to 2, B is going to 1, C is to 3, and then 4, we didn't use 4. Therefore, this is 1 to 1, but not 2. Okay, so anak panah ni gerak sikit lah. Dia pergi sampai 2 sebenarnya. Okay, next. So kalau kita guna semua dalam B, kita akan panggil dia sebagai onto. Kalau kita tak guna semua dalam B, kita panggil dia sebagai not onto. Okay, next. Right, so similar happen over here. Okay, so we have A going to 1, C going to 1, B going to 2. So this is many to 1. Why many to 1? Because A and C, both of them are going to 1 on B. So this is many to 1. And we're going to call them as on 2 because we use everything inside the B. Okay, so for the second one, on the right hand side over here, we have A, B, C. Okay, so A, B, C going to the same number, which is a 2. So this is many to 1. But since we didn't use 1, we didn't use 3, so this is 1 to many to 1, but not on 2. So many to 1 and not on 2. Okay, next. Okay, so now if fx is equal to x over 2x plus 5, find the first one we need to find what is f of x. And then the second one, f of 4 over x. Okay, so how do we find f of 3x? So do you see over here? This is fx. Okay. Replace the x here with 3x. Okay, so replace the x with 3x. So every time you see the x, make sure you replace them with 3x. So I have x over here. I'm going to replace them with 3x. I have x below here as well. So I'm going to replace them with 3x. Okay, so what happened? So it will become 3x over 2 multiplied with 3x, and that's with 5. Okay, so simplify your numerator after that. 2 times 3 is 6. So we got 3x over 6x plus 5. Okay, so we can simplify them further. So that is the simplest form. So done with A. Okay, so now let us do B. How B? Okay, so for B, we have F 4 over X. What do is that every time you see the X, you should be 4 over X. Okay, so they will become 4 over X over 2 multiply with 4 over X and then plus with 5. Okay, so what do we do next? Okay, so if you have fraction, right, over here, this is a fraction. But for your fraction, you actually have another fraction at the top and another fraction at the bottom. So what do we need to do is that we need to simplify them until we have a single fraction. So kena simplify sikit lah. Okay, so firstly, we are going to simplify our denominator. So this is 2 multiplied with 4 over x plus 5. So we are going to simplify them. So that one will become 8 over x plus 5, or we can say that it's supposed to be 8 plus 5x over x. Okay, so you're going to simplify them. So they will become 8 plus x over x. So 4 over x over 5 plus 8 plus 5 x. And then since we're dealing with a fraction, so we can actually take the reciprocal for them. So kita boleh pusingkan dia sebab kita bahagi dengan fraction kan. Okay, so they will become 4 multiply with x over 8 plus 5x. Macam tak boleh tulis je. Lagi sekali lah saya cakap. Apa? Laptop saya kena reformat. So dia nak link dengan saya punya tablet tu, dia ambil masa sikit. Sebab saya kena install balik. So disebabkan itu, kita pun menggunakanlah apa yang ada. Okay, so 4 over x. Okay, so you're gonna do times x over, oh, yang senang ke, payah gila nak pakai benda lah ni. 8 plus 5x. Okay, and then you're gonna cancel the x and the x. So they will become 4 over 8 plus 5x. That is basically the simplest one. How do I know that is basically the simplest one? Because I only have one fraction. So I don't have any at the top, any fraction at the bottom. So I simply left a single fraction. So those are the simplest form. Itu yang paling simple dah lah tu. Okay, so let us proceed with the next one. So now, vertical line test. When do we vertical line test? Okay, so vertical line test, we use them when we want to test if a graph represents a function. Have a lot of graph, different types of graph, but how do we know that those graphs represent a function? So we have to do a vertical line test. So do you guys remember the function? The function have of relation, either 1 to 1 or many to 1. So belakang tu kena 1 kan, either 1 to 1 or many to 1. So in order to test whether we have a function or not, we are going to do a vertical line test. Okay, so the graph represents a function if each vertical line drawn through our main cuts the graph at only one point. Okay, so when we draw a vertical line throughout the graph, starting from the left hand side to the right hand side or right hand side to the left hand side, the line must cut at only one point. So if let's say the is from x equal to 1 until x equal to 2, then the graph does not represent a function. So we got to do a vertical line test. Okay, so consider whether the graph represents functions. First one. Okay, so this is basically the graph for a lawn actually. Okay, so draw a vertical line test. Okay, so make sure you have your ruler ready and then a pencil as well. Okay, so draw a vertical line. Okay, so for example, if let's say I draw x equal to 2, so those are x equal to 2. Okay, so how many does it cut? Does the vertical line cut? So you can actually see of there, the line cut at only one point. The line cuts the graph at only one point. Therefore, this one represents a function. It is a function because we only cut at one point. So you can actually from the left to the right hand side, at most it will be one point. They will cut at only one point. Okay, so now the second one. Okay, so now again, draw a vertical line. So draw a vertical line. Okay, so basically if I draw a vertical line over there. Okay, so draw a vertical line over here, over here, over here. Choose anywhere. As you can see, you will cut at 2 points. Okay, so the line cuts the graph at 2 points. Therefore, this is not function. Definitely not a function because we cut at 2 points. So make sure whenever you have your graph, vertical line test them first. Are they a function or not? Oh, kalau ABC seronok sikit lah kita bagi kan. Ada function, bagi-bagi graph sikit, nanti tak ingat function tu apa. So you must remember to check whether this is a function or not. You must make sure the line cuts at only one point. Okay. One-to-one function. Okay, so whenever we are talking about function two things. Many to one or one-to-one, but we are focusing on one because only one-to-one function has the inverse function. So that's the reason why we are more focusing on one. Okay, so a function for which every element of the range correspond to exactly one element main. Okay, we have one in range. Okay, so that is the reason why this is one. So one element in the domain. So on the left side here, this is domain. On the right hand side, range. So one domain, one range. One domain, one domain, one range. One domain, one range. So this is one to one. So this is not one-to-one function. Why? Because both 0 and 1 go to 4. So this is not one-to-one function, but this is many to one. Not one. Those are many to one. Because you have two on the left, one right. So many to one. Okay, next. Okay, so basically how can we whether do we have one-to-one function or not? Okay, so by doing a vertical test, you know that you can either one or one-to-one function. But now basically I want to look at one-to-one function. How can I determine those are one-to-one function? Okay, so actually have two methods. The first one is the graphical and the second one is the method. Okay, so method, what to do? Need to do something called the horizontal line test. So just now we did a vertical line test. So vertical line test is to determine that you have a function, but now we need to do a horizontal line test to determine that this is definitely one-to-one function. Okay, so by doing a horizontal line test, you should check that the line must cut at only one point only. So the same thing, the similar thing with vertical line test, they must cut at only one point. Cumanya kalau untuk vertical, dia boleh ada dua keadaan, either one atau many to one. But for horizontal line test, this is specifically for one-to-one function. We want to determine whether are they one-to-one or not. Another one is something called as the algebraic method. So method, what you should do is that you are going to write down fx1 equal to fx2. So you're going to look at the function fx fx. So from fx, you are going to replace with x1 and you are going to replace with x. So substitute x1 on the left, substitute x2 on the right. What do you need to make sure is that you have to check whether are you going to get x1 equal to x2 at the end. At the end of that, are you going to get x1 equal to x2 only? If you get x1 equal to x2, then this is definitely one-to-one function. If let's say you are given two different value, then this is not one-to-one function. Okay, so again, I repeat, in order to determine whether the graph or the function, you have two methods, either graphical or algebraic method. If you want to use a graphical method, that means you have to sketch the graph, do the horizontal line test, make sure the line cuts at one point only. If you are doing the algebraic method, make sure you know what is the function. You are going to substitute f1 equal to fx2, which means that you take the function, you replace the x with x1 on the left, replace the function with x2 on the right, and you're going to check, are we going to have x1 equal to x2 at the end? If we are going to get x1 equal to x2 at the end, then this is one-to-one function. But if let's say we have more than x1 equal, that's not one-to-one function. Okay, so any x1 or x2 inside the domain A yang terbalik ni, dia bukannya terbalik, betul, dia for any. Shortcut lah. Maths ni kadang-kadang dia, mathematician ni dia tak tahulah, pemalas sikit nak menulis kan. Yang ni pun kalau you tengok nampak macam nak panah kan, tapi yang ni sebenarnya dia implies that. So if x1 equal to x2 implies that x1 equal to x2 for any x1, x2 are an element of domain for F. Yang ni an element of, yang ni for any ataupun for all ke for any ke boleh je. Okay, next. Okay, so now example 2. State whether the following graph represent one-to-one function. Okay, you are given a graph. Fx equal to x, x minus 2. So this is basically a quadratic graph. Definitely a smile because we have a positive x squared. So definitely a smile graph. Okay, so a smile graph cutting at 0 and 2. Okay, how do we check whether this is one-to-one function or not? Okay, so to check whether they are one-to-one function or not, we have to do something called the horizontal line test. Okay, so do the horizontal line test. So cut them at any point. So for me, I choose y equal to k. So kalau nak mudah, y equal to 3 ke, y equal to 4 ke, up to you. Choose any number. Okay, so once you cut, you should be able to see that the horizontal line cuts at 2 points. Since the horizontal line cuts at 2 points, f is definitely not one-to-one function. Definitely not, because we cut at 2 points. Okay, so now the second one. This is by using graphical method. Of course, later on you need to know how to sketch them first before you can see are they one-to-one or not. Of course lah, nanti kita akan belajar lah sketching tu belakang sikit. Tapi yang depan ni kita dah ada graph lah. Kita hanya nak determine saja. Okay, so now the second one. You have fx equal to x cubed minus 3. So it's look like x cubed, but we are going to shift them down. Okay. Right, so this is x cubed minus 1. We want to test whether are we having one-to-one function or not. So you need to draw a horizontal line test. Draw a horizontal line. So you can do your horizontal line anywhere. Kalau untuk saya, biasanya saya akan ambil ruler, saya gerakkan dari atas sampai bawah. Atas bawah, atas bawah. Sebab nak check ada tak dia cut at 2 points. Okay. So now, basically when you draw your line, your horizontal line, you should be able to see that the line cuts at only 1 point. So the horizontal line cuts at only 1 point, therefore f is one-to-one function. kenapa kita tak cut vertically? Kalau kita cut vertically, dia boleh ada dua keadaan. Satu many to one, satu lagi one to one. Kita nak specifically dia adalah one to one. So kita akan buat secara horizontal. Horizontal untuk one to one. Kalau awak nak check dia function ke tak, yang ni sebab kita memang dah sure soalan ni memang dah cakap dia adalah function. Okay, so kita memang dah tahu dia adalah function. You can actually test kalau you buat vertical line untuk yang inilah kan. Kalau kata you buatlah vertical line you gonna see that you actually cut at only one point. Okay, so this is definitely a function. Tapi function tu dia ada dua jenis. Either one to one ataupun many to one. We only want one to one. So that's the reason why we are doing a horizontal line test. Okay, so similar thing with this one. If you do your vertical line, you will cut at one point. So you know for sure that this is either one to one or many to one. How to determine they are definitely one to one function? Then you have to draw your horizontal line. So bila kita buat horizontal line, baru kita jumpa kata oh we only cut at one point. So this is definitely one to one function. Boleh lihat? Oh, I forgot to check. Is the sound okay? Is everything okay? Saya lupa nak tanya sebab tadi saya start lambat sikit. Okay ke? Ngalik. Banyak sangat. Dia tiba-tiba je hari ni semua benda it didn't work. Oh. Macam mana? Okay. Sound okay. Tapi tak tahu faham ke tak Ambil. Okay, never mind. I'll give you the mind map later on. I'll show you the mind map. Okay, so now determine whether the following function are one-to-one. Okay, so just now we are doing a graphical method where we did a horizontal line test. So now this is by using algebraic method. Okay. So fx equal to 2x plus 3 for x in real number. Okay, so we have to determine they are one-to-one function, but this time by using algebraic method, so we have to start from fx1 equal to fx2. Okay, so start with fx1 equal to fx2. So what happened now is that every time you see the x, you have to replace them with x1 as well as x2. So on the left hand side, we are going to replace them with x1. On the right hand side, we are going to replace them with x2. So ada dua lah. Kiri ganti x1, kanan ganti x2. Okay, so now they will become 2x1 plus 3 equal to 2x2 plus 3. And then of course, you're going to deduct 3 on both sides and then divide both by 2. So tolak 3, bahagikan dengan 2. So we are going to get x1 equal to x2. Okay, so what do we have over here? So fx1 equal to fx2 thus implies that x1 equal to x2. Therefore, this is definitely one-to-one function because I don't see anything else other than x1 equal to x2. So f is definitely one-to-one function. Okay, so now the second one. The second one can be a bit tough, I guess. Okay, the second one, if fx1 equal to fx2, we have a quadratic function, right? I forgot to copy down the function. Okay, never mind. Okay, so we have x squared plus 2x minus 5. So you replace them with x1 on the left hand side, x2 on the right hand side. Okay, so x1 on the left, we have x1 square plus x2 x1 minus 5 equal to x2 square plus 2x2 minus 5. Okay, so of course you plus 5 on both sides. So dua-dua kita buat tambah 5. So we are going to get x1 square plus 2x1 equal to x2 square plus 2x2. Okay, so now this is totally up to you. How are you going to factorize them? Okay. Kenapa totally up to you? Some people, when they factorize, they factorize x square and x square. Some people, they might want to use computing the square. So tengoklah, ada certain orang dia ada cara yang berbeza untuk setiap orang. Some people might want to use computing the square. Some people might want to factorize them by using the algebra method. Okay, so this is computing the square. Okay, so x1 square plus 2x1. So I'm doing completing the square. So this one is x1 plus 1 square minus 1 equal to x2 plus 1 square minus 1. And then of course we plus 1 on both sides. So we are going to get x1 plus 1 square equal to x2 plus 1 square. Okay, so now please tell me, are you going to get x1 equal to x2? Adakah kita akan dapat x1 equal to x2? Atau adakah kita akan dapat term lain juga? Jeng, jeng, jeng. Okay, so try to solve them. Are you going to get x1 equal to x2 only or not? Okay, so I'll give you around 2 minutes for you to try and solve them. Are you going to get x1 equal to x2 only? Sekejap saya kena check kehadiran jap. Okay, berapa orang lagi tak key in? 30 lagi tak key in. Okay, so now let's see what's the answer. Okay. Okay, so what's the answer? Okay, so basically we have x1 plus 1 square equal to x2 plus 1 square. So you can actually do square root on both sides. However, we have an even power. So whenever we have an even power, we need to keep in mind that whenever we are going to apply the square root, we have to put plus and minus. Sebab kita ada even power. Okay, so what will they become? So they will become x1 plus 1 equal to plus and minus x2 plus 1. So you're going to take each of them. So either x1 plus 1 equal to x2 plus 1 or x1 plus 1 equal to the negative of x2 plus 1. So we can actually separate them into two. The first one is a positive, the second one is a negative. Okay, so what happened next? Okay, so you're going to let x1 as the subject, of course, on the left hand side, making x1 as the subject. So we are going to get x1 equal to x2 on the left hand side. Obviously, you're going to deduct on both sides. So that's the reason why you are having x1 equal to x2. However, on the right hand side, if you are making x1 as the subject, you are going to get x1 equal to negative x2 minus 2. Okay, so we don't simply get x1 equal to x2, but we do have another x1. So what does it mean is that this is definitely not one-to-one function. Definitely not one-to-one function because we have two different values. So x1 equal to x2, x1 equal to negative x2 negative 2. So since we have two different value, fx is not one-to-one function, definitely not one-to-one. Unless kita buat restriction untuk domain, then dia boleh jadi one-to-one function. Tapi since dia memang soalan dia domain dia adalah real number, so dia bukan one-to-one function. Boleh tengok kot kalau kata kita lukis kuadratik kan, and then kita buat a horizontal line, they always cut at 2 points. So that's the reason why we know this is definitely not one-to-one function. Okay, so if I can summarize them, so this is of course the summarized part. Okay, so how do we know whether do we have a functions or not? You need to do something called the vertical line test. By doing a vertical line test, we can easily determine whether do we have a function. Function, they only consist of two relation, either one-to-one or many-to-one. Yang ni yang biasanya kita panggil one-to-one function. Kalau dia one-to-one relation, then dia adalah function, so dia one-to-one function lah. Okay, so how do you know whether you have one-to-one function? There are two methods, either by using the graphical method or you can use algebraic method. By using graphical method, you need to do something called the horizontal line test. By doing the algebraic method, you are doing something like fx1 equal to fx2, making sure that you only get x1 equal to x2. Okay, so again, I repeat, vertical line test. When you are doing a vertical line test, you might get either one of these two. Either you have a one-to-one or many-to-one. But to actually determine whether do you have one-to-one or not, you have to do either graphical method or algebraic method. Okay, so you must really understand about this one-to-one function because our inverse only involve one-to-one function. So ini yang penting lah, kena faham lah benda ni. Okay, so start pada vertical line, dia boleh ada dua relation. Nak tahu cari satu one-to-one ni, ada dua method. So those are my map. For whatever I already explained earlier. So ini adalah my map dia. Okay, next. Hopefully dah screenshot. Kalau tak screenshot, saya bagi masa 5 saat untuk screenshot. 5, 4, 3, 2, 1. Habis. Okay, so now this is the part where most people will have some problem, where we're gonna call them as the sketching part. Okay, so sketching graph of a function. Okay, so how can we start? How can we sketch a graph of a function? Okay, so the first thing that you should do, you must know what is the basic shape of the graph. Okay, so you must understand or you must remember how does the graph looks like? So for example, how does a straight line looks like? How does a quadratic looks like? How does a cubic looks like? How does a reciprocal graph looks like? How does an absolute value graph looks like? A square root looks like? Exponential and logarithmic function. We have lots of different types of functions. So you must know what is the basic shape of the graph, because if we know what is the basic shape of the graph, we can easily find what is the intercept, vertex and so on. So kita mesti kena faham dulu basic shape, apa yang ada dekat graph tu. Baru kita boleh tahu kita nak cari apa lah. So those basic shape. Okay, so how to understand the basic shape? So for me, I'll say prepare an A4 paper and make sure to write down the basic shape of the graph, and then make sure kena ada example juga lah nanti dekat sebelah kanan tu untuk guide. So later on, I'll give you the notes for this one yang saya dah buat lah, yang saya dah bahagi-bahagikan. So nanti tengok dekat situ lah macam mana. Okay, so based on the basic shape of the graph, we are going to find the y or x-intercept. Okay, so x-intercept, that means you are looking for the value when y equal to 0. So bila y sama dengan kosong, apakah nilai x-intercept? Y-intercept, that is when x equal to 0. So you're going to substitute x equal to 0 and find out what is the value for the y. Why do they say if any? Sometimes you are not going to get the x-intercept or y-intercept. So that's the reason why they say if any. So if you have any x-intercept or y-intercept, it will be quite helpful if we can easily calculate them first. So those are the second one. The third one, vertex. Vertex is normally for a quadratic graph, a smile graph, or an absolute value graph. So dia ada puncak, ada yang paling rendah, paling tinggi, paling rendah. So those are the vertex. Ada the maximum or the minimum point. So those are the vertex. Of course, if any, because not everything has a vertex. For example, straight line, you don't have any vertex. So that's the reason why we write them as if any. Vertical or horizontal asymptote. So vertical or horizontal asymptote, again, if any. Why if any? Not everything has a vertical or horizontal asymptote. So the thing that has a vertical or horizontal asymptote is the logarithm function, and then the exponential function, as well as one more, the reciprocal function. So you only have a vertical or horizontal asymptote for 3 types of function, either a logarithmic function, exponential function or reciprocal function. Ada 3 je yang ada asymptote ni. And then symmetry of the graph, of course, if you have a quadratic or you have an absolute value, you have a vertex, right? So you definitely need something called the symmetry of the graph. Maksudnya masa kita lukis graph tu, katalah kita tengah lukis smile kan, janganlah herok sangat smile tu, dia ada symmetry sikit lah, kita nampak titik paling rendah kat mana and then dia naik balik. Okay, and then you need to find out the domain and the range. This is very useful, especially when you have an asymptote. So you got to really make sure what is your domain and what is your range. Okay, so those are the basic thing for sketching a graph. Okay, let us refer to the first one. Basic shape of a graph. So those are the things that you have to remember. Okay, the first one, we have something called the constant term. Okay, so constant term, for example, y equal to k. So you simply draw a horizontal line. So those are y equal to k. Okay, so for example, y equal to 5. So this is the constant function, y equal to 5. Line macam line apa? Line tiit. Line kat machine tu kan. Tiit. Macam tu lah. Garis sama data. Okay, so next. Linear, y equal to mx plus c. So this is a linear graph. A linear graph, it can either going up or it can go down. Okay, so what do you need to find for a linear function? You need to know what is the gradient, because we need to decide, is it a positive gradient or a negative gradient? So if it is a positive gradient, we are going to draw something that is going up. Maksudnya kita tengah mendaki bukit, so start pada bawah, naik. If we have a negative gradient, then that means we are going down. So tergolek jatuh. Okay, so what is C? C is the y-intercept. So do you remember y-intercept? That means x is equal to 0. So when you look at the function, you got to substitute x equal to 0. So that one will give you the y-intercept. Okay, so what happened when you have a positive or negative gradient? So positive gradient going up, negative gradient going down. Okay, and then when you substitute with x equal to 0, you are going to see this number over here, this is 5. Okay, this number over here, when you substitute x with 0, you are going to get 3. So titik ni kita tahulah titik ni adalah 3. Okay, so those are for linear. So linear, you might want to write down y as the subject. So y as the subject, and then simply find out what is the y-intercept and then draw lah graph tu, naik atas ke turun bawah. Okay, next. So now we have something called the quadratic. So how does a quadratic looks like? So quadratic is fx equal to ax square plus bx plus c. If you are very good with completing the square, I do advise you to do completing the square at this step. If you know how to do completing the square. If you didn't know how to do completing the square, then you might want to memorize that h is equal to negative b over to a. So up to you. What do you want to do? If you are really good with your completing the square, then you can do completing the square. If you find that completing the square is a bit tough, then you might want to use the formula. Kadang-kadang tough, kadang-kadang rasa macam nak cepat sikit kan. Okay, so make sure to calculate your vertex. Okay, so hk from completing the square, or if you have h equal to negative b over to a, then k is simply substitute the x with negative b over to a. Okay, and then if a is a positive number, then this one is a smile graph. If you have a that is a negative number, then that means this is a set graph, open downward, a set graph. Open upward, open downward. Okay, so those are the quadratic graph. Okay, vertex. Vertex is where? This point over here, which is the lowest point. So if you have a smile graph, that means the lowest point over here. This is negative b over to a. Nilai x dia adalah negative b over to a. Dah dapat nilai, nanti ganti baliklah dalam fx ni. Nanti dia boleh dapatlah nilai y dia berapa. So those are the lowest point. So make sure lah janganlah kata vertex duduk kat kiri ni pula. Vertex mesti titik yang paling rendah sekali. Kalau kita letak bola, bola tu takkan jatuh lah. So dekat sini je. Okay, so if you do a set graph, then the vertex is at the highest point. So on top over here, so this value of x is negative b over to a. You substitute the value of x inside your function. Those will be the value of y. So nanti kena kira lah. Titik maksimum berapa, titik minimum berapa. Okay, so how to check whether does the graph cuts our x-axis or not? So kita akan guna EQN. Kalau keluar imaginary number, then graph kita mungkin duduk macam sebelah kiri ni lah. Tak sentuh langsung x-axis. So kita akan guna EQN lah nanti. Kalau yang ini kita guna EQN, kita akan dapat dua nilai. Dan dua-dua adalah real, of course. Dan nanti kita akan guna calculator je lah untuk yang ni. Just nak make sure dia potong dekat berapa point. Okay, next. Okay, we have fx equal to x square minus 4x plus with 3. Okay, so you're going to calculate negative b over to a. So negative b over to h equal to negative times with negative 4 over to a. So you are going to get h is equal to 2. So go back to fx, substitute x with 2. So you are going to get negative 1. So we have the minimum at 2 and negative 1. Okay, so A is greater than 0, open up. So maksudnya graph dia kena smile lah. Graph yang smile and the lowest point will be at 2, negative 1. Okay, so this is basically how the graph looks like. So a smile graph, the minimum here is 2, -1. And then macam mana nak tahu nilai 1 dengan 3 ni, kita akan guna EQN lah. Ataupun kalau boleh factorize completely. Kalau rasa macam payah sikit, kita guna je EQN. Pastikan dapat dua nilai, 1 dengan 3. And then how do you get this value over here? You gonna substitute with x equal to 0. Okay, so letak part C dulu, x, letak part C Y. Make sure you have your vertex ready, 2, -1. And then simply draw a smile graph. How do we know this is a definitely a smile graph? Because this is an open upward. Nilai A dia besar daripada kosong. Okay, next. Right, so let's say you have fx equal to the negative of x minus 1 square plus 2. So this is already in completing the square form. So kalau benda dah dalam bentuk completing the square, better kita compare saja terus dapatkan nilai h dengan k. So kita ambil nombor yang berada dalam square, samakan dia dengan kosong, so we are going to get 1. And then the number at the back, those will be k. So yang tadi belum buat computing the square kan? That's the reason why we are using the formula for negative b over 2a. This is already in computing the square form. So I simply take the number that is square, let them equal to 0. So x will be equal to 1. Take the number at the back. So those one will become k. Okay, so this is definitely a set graph. How do we know this is a set graph? Because we have a negative sign in front here. So negative sign, this is definitely a set graph or open downward. Kenapa dia kata greater than 0, less than? Lupa nak tukar lah ni. Sekejap Nanti sekarang budak-budak ni dia okay, open down. Ow. Aci lah. Okay, so open downward. So this is definitely a set graph. So the highest point over here is 1 and 2. Okay, so 1 and 2, and of course you can actually, if you want to, you can actually expand them and then check or verify that you will have 2 point over here, 1 here and 1 here. Ataupun kalau tak nak expand dan cari nilai dia berapa, you can actually let this one equal to 0. Yang ini kalau samakan dia dengan kosong, kita akan dapat 2 nilai x lah. Pun boleh jugalah. Okay, so those are for the quadratic. So untuk quadratic, benda yang paling penting untuk saya kata mesti kena cari vertex. You must make sure you know how to find the vertex, and then make sure you know what is the shape of the graph, and then you must know where does the graph intersect. So does the graph intersect the x-axis or not? So yang tu kita akan pakai EQN ke apa ke, kita akan cari nilai x dia. Kalau ada nilai x, maksudnya graf tu kena sentuh paksi x. Kalau tak ada nilai x, so graf tu terangkat lah. Dia tak akan sentuh langsung paksi x tu. And then of course, you must find out whenever x equal to 0, what is the value for y. Okay, next. A cubic graph looks like this: ax cubed plus bx squared plus cx plus with d. Okay, so how does a graph for x cubed plus 5 looks like? So x cubed bentuk dia mesti bentuk dia macam huruf N macam tu. Start dari kanan. And then plus 5, so maksudnya kita mesti sentuh dekat 5. Inflection point dia dekat 5. Over here. Okay, nampak? Ni yang bentuk yang saya kata macam bentuk N tu. Okay, so you start from the right hand side because this is x cubed, positive x cubed. So start from the right hand side. Once you see the 5, and then you're gonna flip them. So kita tukar dia punya concave ataupun apa, pusingan dia, cengkung dia tu. So concave dia kita tukar. So this one is x cubed plus 5. Okay. The next one is x squared 3 minus x. So x squared 3 minus x. This is also a cubic except that we have multiplicity at x squared and then 3 minus x multiplicity dia adalah 1 lah. Yang dekat x square ni multiplicity dia adalah 2. So how does the graph looks like? Okay, so basically when you expand them, you are going to get negative x cubed, right? We are just want to see whether is it positive x cube or negative x cube. So kalau kita tahu dia adalah negative x cube, masa kita lukis mesti kena start daripada sebelah kiri. Okay, so make sure you are ready with the 0 as well as 3. So 0 here, 3 is over here. This is 3. Okay, so your graph must start from the left hand side because this is negative x cube. So you must start from the left hand side because this is negative x cube. Okay, however, when you meet the 0, the multiplicity is actually 2. So when you meet the 0, since the multiplicity is 2, you have to flip them back. So kita kena patah balik naik atas. So kita start dari kiri, jumpa kosong. Tapi kosong multiplicity dia 2, so naik atas balik. And then you should see another factor over here which is 3. So naik atas tapi tak boleh jauh sangat lah sebab nanti kena turun balik jumpa 3. So pak. Right, so this is how the graph looks like. Okay, so kalau kata nak belajar banyak sikit, yang ni kena tengok video yang saya letak dekat channel ni. Sebab yang tu saya proceed satu-satu kan, memang saya fokus satu-satu graph lah. So kalau nak mahir lagi memang kena tengok yang tu. Sebab cubic je dia ada 3 jenis cubic. Dia ada multiplicity dia 1 semua. Ataupun dia ada yang macam ni, ada kuadratik. Ataupun satu lagi dia dalam keadaan yang cube macam ni. So dia ada 3 keadaan untuk cubic ni. So kalau nak belajar banyak sikit memang kena tengok yang nota video tu lah kiranya. Okay, so sekarang set is fx equal to the square root of ax plus b where ax plus b is greater than or equal to 0. So normally for me, I prefer to look at this one, ax plus b. So I'm going to take whatever inside of the square root, let them to be greater than or equal to 0. So this is very useful for me because I need to know where does the graph go. Is it going to the left or is it going to the right hand side? Okay, so for example over here, take x minus 2 greater than or equal to 0. I know that this is x greater than or equal to 2. So when I draw my graph, I must start from 2. So this one I start from 2 and then going to the right. Ni atas lah. Another one. If I have fx equal to the square root of 1 minus x, so I'm going to let 1 minus x be greater than or equal to 0. So I know that x will be less than or equal to 1. So x less than or equal to 1, make sure you have your axis ready. So where is 1? So x is less than or equal to 1, that means we are going to the left. Okay, so that is how the graph looks like. Okay. So yang ni senang lah sebab dia positif saja. Okay. Next. We just want to know the basic shape, right? So that is the basic shape for the graph. Dia kalau kata kuadratik biasa kita ada smile kan? So you cut the smile into half. So that is how they look like. So set ni dia macam separuh daripada kuadratik tu. Tu yang bentuk dia nampak macam pelik sikit tu. Sebab kita potong daripada kuadratik kan? Kita potong separuh je. Okay, so those are the set. We have something called the reciprocal. So for reciprocal, you need to find out what is the horizontal and the vertical asymptote. So horizontal asymptote, normally y equal to 0. So if you don't see any number at the back, that means horizontal asymptote is when y equal to 0. The vertical asymptote, you have to refer to your denominator. So in this case, the denominator is x equal to negative c over b. So those are the vertical and horizontal asymptote. So bila kita lukis, kita kena ada horizontal dan juga vertical asymptote. Baru kita lukis graf kita. So graf kita kena rapat dengan asymptote lah. Mesti kena rapat dengan asymptote. Okay. So those are the first one. The second one. Okay, lagi sekali lah. Kita boleh tengok dia mesti kena rapat dengan asymptote. Yang ini biasanya kalau kata kita nak tahu dia dekat mana, kita akan test nilai lah. Contohnya kalau biasanya saya akan ganti X dengan kosong. So saya boleh tahulah graf saya dekat mana. Okay, later on we see how. Okay, so this is how the absolute value look like. So absolute value dia mesti kena bentuk dia V, sharp V ataupun inverted V. Tapi mesti kena sharp sharp. Dia tak boleh nampak macam kuadratik. Kuadratik dia macam ayu je macam tu sebab dia kena smile kan. So yang ni dia kena sharp V. Sharp. Okay. Lepas tu sharp going down. Okay, so macam mana kita nak tentukan nak buat sharp ni dekat mana? Sebab tu kita kena cari vertex. So masa kita lukis absolute value, ambil nombor yang dalam modulus tu, samakan dia dengan kosong. So nanti kita akan dapat tahulah nilai X kita berapa. Lepas tu ganti balik nilai X, nanti dapatlah K yang kat belakang tu. So kita tahulah kita punya vertex, nilai dia berapa. Okay, so ini shape. Shape je dulu, faham shape dulu. Okay, next. Piecewise function. Okay, so this is normally what you are going to have. Piecewise function, that means we are going to use 2 or more function. But then we have to restrict the domain for each of them. So for example, this kind of function, for x less than 0, we are going to use negative x square. So negative x square tu yang set graph tu kan. So kalau set graph tu, dia akan go from negative infinity to infinity. But they say that x will be less than 0. So daripada kita lukis set tu, kita potong separuh. Kita hanya akan ambil yang sebelah kiri saja. And then x plus 5. X plus 5 adalah satu garis linear. They go from negative infinity to infinity, but we only want the positive part. So you need to make sure you start from 0 going up. Okay, so on the right hand side over here, this is for x plus 5. On the left hand side over here, this is negative x square. Okay, so macam biasalah, tengok kat sini kan, sini tak ada dan circle sebab dia tak ada simbol equal kat sini. This one you must use the dan circle because you have the equal sign exactly at 0. Okay, so those are the piecewise function. So piecewise function ni sebenarnya kita kena lukis macam biasa saja. Cuma bezanya adalah kita kena lukis dia ikut domain. So kena pandai lah domain tu apa. Sebab tu kita belajar domain. Oh, ada lagi sketch the graph for the following function. X square minus 9. Okay, how does the graph looks like? X square minus 9. So kalau ikut yang ini kena tahu dululah shape dia. Is it a smile or is it a sad graph? Okay, so first kali nilai A. A is greater than 0. This is open upward. Or we can say that this is definitely a smile graph. And then what is the vertex? So this is exactly in completing the square form. So I can take this one, let them equal to 0. So x is equal to 0. And then take the number at the back. So those will be h. So 0, negative 9. So when x is equal to 0, y is equal to 9. So that is basically how the graph looks like. Okay, so when x is 0, this is 9. So this is how I know my vertex. And then you're going to use your EQN. Then you can get two different value of x, either x equal to negative 3 or x equal to 3. Okay, so kita guna EQN je. Kita nak tahu nilai dia berapa. Okay, so those are for quadratic. Okay, so now for the set. Okay, set, you simply take this number inside of the set, you let them to be greater than or equal to 0. So x plus 5 greater than or equal to 0, x will be greater than or equal to negative 5. So ready with the axis, x axis and y axis. And then make sure you have your negative 5. So this is negative 5. We need to decide, is it going to the right or is it going to the left? So based on the domain, we have greater than negative 5. So that means we are going to the right hand side. Okay, so that is the square root of x plus 5. Banyak lagi ni example ni. Sekejap saya check ada berapa lagi. Ada lagi 10 kau. Tak apa. Sekejap je. Sikit lagi. Okay, so now this is absolute value of 2x minus 5. So you're going to take inside of the modulus. So this is absolute value. So absolute value a v or a. So kena tengok dulu modulus, simbol dia positif, so v. So you need to know what is the minimum point. So minimum point, you let them equal to 0. So you are going to get 5 over 2 as well as 0. So those are your minimum point. And then ready with your x-axis, y-axis, ready. And then make sure you have your vertex 5 over 2, 0. And then simply draw a V. So kita start daripada 5 over 2, 0. So this is the point. 5 over 2, 0. That is my vertex. And then I simply need to draw V. Line with the absolute value graph. So you must know where is the V. Where is the vertex? Okay, next. Okay, so we have 1 over x minus 2. So of course, this is a reciprocal function. So we must draw our asymptote. So you let your denominator equal to 0. So those one will become your vertical asymptote. The horizontal asymptote, I don't see anything at the back over here. So the horizontal asymptote is simply y equal to 0. So for vertical, you're going to take this one. You're going to let them equal to 0. Okay, and then at the back over here, this is plus 0. So that means I know for sure my horizontal asymptote is y equal to 0. Okay, so horizontal asymptote, vertical asymptote, make sure you have them ready. Okay, so where is the horizontal asymptote? Horizontal asymptote is over here. Dia biasanya bila dia duduk atas line ni kadang-kadang kita tak lukis. Tapi untuk yang beginner, better lukis lah. Okay, and then you need to substitute one value. So untuk saya akan ganti x dengan 3. So kalau saya ganti x dengan 3, saya akan dapat 1 per 1. So kalau saya ganti x equal to 3, I get the value for y equal to 1. So where is 3? So for example, 3 is over here, right? Where is y equal to 1? At the top, dekat atas. So saya tahu graf saya akan duduk dekat kuadran yang inilah. So kuadran yang ini bersama dengan kuadran yang bawah. Sebab dia mesti kena macam ni. Okay, so now sketch the graph. Okay, so dapatlah graf dia apa. So biasanya kalau asymptote tu dia akan pecahkan graf kita lah kepada beberapa region. So biasanya kalau untuk saya akan ganti nilai because I find it's a waste of my brain power to memorize positive negative. So biasanya saya suka ganti nilai lagi lah. Okay, next. Domain and range. Okay, so domain is the set for the value of x. And then range is the value of y. So domain is the value of x, range is the value of y. Okay, so two method to find the domain and range. So you can actually do the graphical method where you must draw the graph first to find the domain and the range. The second one is by using algebraic method. Okay, so graphical method. Okay, so x axis represent the domain, y axis represent the range. So as you can see over here, this is the x axis. So everything on x is the domain. And then everything on y, this is the range. So kita akan tengoklah nilai apa yang boleh letak dekat x. So itu adalah domain. Nilai apa yang boleh letak dekat y, itu adalah range. Okay, so domain, all possible value of x. And then, right, so normally for the domain, we can say that all possible value of x except for three things. When you have a division by zero, when you have a negative value under a square root, and then when you have a lot of zero and negative value. So biasanya untuk domain memang by default negative infinity to infinity unless you have a reciprocal function, because you need to make sure that when you divide your x, you are not going to get zero in your denominator. If you have a square root, you need to make sure that the thing inside of the square root is not a negative number. And then if you have a lot, you need to make sure to avoid zero as well as negative value. So biasanya by default, dia memang negative infinity to infinity. However, when it comes to these special cases, we have to be extra careful, which is a reciprocal function, division to reciprocal, and then a square root, and then a log. So kalau ada tiga keadaan ni, domain kena check betul-betul. Kalau tidak, by default kita boleh letak tu real number. So now, for example, fx is equal to 2 over x minus 3. So as you can see, this is a reciprocal function. We must never let our denominator equal to 0. So x minus 3 cannot be equal to 0. Therefore, x cannot be equal to 3. So we will have a restriction for the domain where x cannot be equal to 3. So your domain will be negative infinity up until 3, union 3 up until infinity. So you just ignore the value of 3. So this is for the reciprocal function. Second, when you have a set or a square root, what do you need to do? You need to make sure that the thing inside the set is definitely greater than or equal to 0. So x minus 2 need to be greater than or equal to 0, which means that x must be greater than or equal to 2. So those are your domain where you have 2 to infinity. And then the third one is for the log. We have to avoid 0 and negative number. So x minus 3 need to be greater than 0. So x will be greater than 3. Okay, so those are three main problem with domain. So yang ni kena ingat lah. Domain biasanya akan ada masalah bila kita ada reciprocal function, dia tak boleh sama dengan kosong. Kalau domain, dia mesti kena greater than or equal to 0. Kalau kata log, dia mesti kena greater than 0. Okay, so those are the three main thing. Uish, nak dekat lah. 9.30 dah. Sikit lagi. Okay, so now the range is found by expressing the x equal to in terms of y and then observe the possible value of y. Okay, so for example, fx is equal to 1 over x. So you know that if you refer to here, your x cannot be equal to 0, right? So x cannot be equal to 0. So therefore your domain will be negative infinity up until 0, 0 up until infinity. Meanwhile, for the range, you are going to rearrange them. So you are going to let y equal to 1 over x. And then making x as the subject, you have 1 over y. So again, this is reciprocal. You should never let your denominator equal to 0. So y cannot be equal to 0. So the range will be negative infinity until 0, 0 until infinity. So this is one of the easiest way to find out your domain and range. Okay, so example 5, sketch the graph of the following and then state the domain and range. So saya rasa yang ini saya tinggalkan untuk awak dulu, awak try buat. Nanti untuk next class kita cuba discuss lah benda ni, example 5 ni. Sebab dah 9 suku dah lama dah. Dah tepu dah kan. Bukan awak je lah tepu dengan saya sekali tepu. Okay, so I'll see you guys later lah. So jadi pukul 9.20 lah kot kita start kita punya tutor. So later on I'll give you the link for your tutorial. So I'll see you guys later. Bye bye semua orang. Saya rasa kena tengok balik kot video ni nanti. Sebab dia panjang, kena tengok balik lah kot. Okay, bye bye